Hi guys, welcome to another series of videos which was recently renamed to an introduction to PMM, I believe. The PMM refactor, in fact, sorry. So what we'll do, well, we still have a bit of a hangover from the previous sprint. We didn't quite complete our restoring of CI/CD. Although, to be fair, we're very close now. So if we just go to current, there we are. So we're down to a couple of failures at nightly time and a couple of Valgrind issues. We also had an intermittent fail on the builds, and we resolved all of these issues today, hopefully, in a series of commits. I'll just quickly discuss these commits. So the key problem that we had was that we had this very silly approach of deleting all the folders when we initialized the product utility methods, the products. So let's just have a quick look at what we did here. As you can see here, each product that we support, so these are the reference products, of course, each product we support has this method to recreate a directory, or had this method. And the recreate directly was done on initialization. And this was probably all right, provided you ran the tests in a serial fashion like we do when we're running them locally. But when you're running the methods inside of GitHub Actions, they are, or even in the nightly, they are running in a non-linear fashion. That we basically run as many tests as we can, given the amount of cores available. So they can run in any order. And that means that if you start a test and it deletes the product directory, and then you start another test that's right into the product directory, you may end up getting yourself into a bit of a situation. Now, as it turns out, and this is the reason why there's so many commits to address this issue, we moved away from code generation on every test. What we do now is we have a set of tests that test most of the functionality, but don't actually code generate to the file system. And then we have another smaller set of tests that test the writing to the file system. And this is actually quite a good idea. I don't remember doing this, but it sounds like a sensible thing to do. The reason why that's a sensible thing to do is because we know that writing to the file system more or less works. So we just need to write that once or twice, and we're happy enough with that, just to sanity check. What we really want to do is we want to check the contents of the thing we're about to write, that those actually match what is expectations. That's the code generation test, well, the model production tests. So that separation is useful. It also, I mean, this is not particularly important, but it saves us the time from writing to the file system, as well as sort of the annoyances of writing to the file system. As we've seen, that causes other problems. So what we've done with this series of commits is we simplified the design of the tests, and we made it obvious where we are producing a model versus where we're generating a model, which I think is quite a good thing to do. And we're just waiting for the last commit on this to hopefully close the case on that. We are not entirely sure why it is that Volgrind is still moaning. According to the suppressions we see here, this actually matches the suppressions we had. But just for a laugh, we decided to, well, we made a bit of a kind of wishful commit, which is this guy here, where we just remove a few entries here on the Volgrind suppression. These entries actually match what we see in the output of Volgrind. So there is no good reason to do that. As you can see here, open record. And whilst this looks like a very long symbol, it is actually identical to what we got here. So I'm not really sure why it is that we're not matching. So we're going to have to keep removing lines until Volgrind is happy enough. Hopefully that will solve the problems. So hopefully, to cut a long story short, hopefully that's the end of these nightly issues. It's not quite the end of our CI woes though, because of course we still don't have support for the C++ products. As you can see here, we're not actually building the nightlies for these guys. Reason being, of course, that we are not yet in GitHub Actions for these products, nor are we on the C# project either. So those tasks should really be completed before we start trying to make changes to the code generator. That would not be a good thing, to change the code generator without having confidence that the tests are passing. So with this video, we're going to continue working on that. In fact, to be honest, we are actually going to finish the mopping up of the previous exercise. Also, this is probably worthwhile having a quick chat about. So one of the big difficulties with the software project is you have to, there's a fine line between spending time adding new features versus the maintenance of the existing features. Actually, I just noticed that we've got the screen swapped around. I think that's not a problem because we haven't actually spent too much time in the coding. So I think we can continue recording without having to restart. Because up to now we've been discussing on that screen, so I think it's fine. In fact, let's just double check what will. Yeah, exactly. So hopefully we haven't missed too much. So as I was about to say, we need, given the resources not infinite, we need to decide how we apply those resources. And sometimes it's easy to just add new stuffs without worrying about what we already had there. But that just builds up the technical debt. That then means that when you look at the code again, you find lots of things that are slightly meaningless. One such case is the mock factory. So we created a mock factory originally in order to create the configuration. And then we moved away from the mock factory to towards a builder. I'll just open up these two classes so you can see what I mean. So you go to the main Dogen the API project, which is this guy here. So in the API project, we have a mock configuration builder and a mock factory. So the factory was sufficient at the beginning because we were trying to do something really easy. But then they were superseded by the builder because we needed all these options related to reading the environment variables and so on, which we addressed in previous videos. And now we have both. And of course, we could just let that be and let it slide and say, oh, well, we don't really care about that anymore. Let's go on and do some interesting coding. But if you do that, we're going to have half of the tests using the configuration mock configuration builder and the other half using the mock configuration factory. And when we return to this in 6 months' time, it's not going to make any sense as to why we have these two classes. That's one part of the problem. The other part of the problem is that we left lots and lots of these little flags all over the place. Because as we started changing our understanding of how the flags worked, we moved them around, but we never really tidied them up. And finally, if we look at our model producer, we have a lot of methods here, as you can see, and all of these are in use at the moment, but it doesn't really make a lot of sense to have this many methods, I don't think. Sorry, the dog seems to be barking at present. It doesn't really make sense to have so many methods, really, such as, for example, creating the configuration and so on. So really, before we move on, and while this is fresh in our heads, we really want to get rid of the factory, get rid of all these methods, and end up with just a single way of doing things. That's, of course, easily said than done, because we now need to remember how these things were being used many moons ago. So as you can see here, all these guys here are using different incantations. And I think this might be easier than we thought originally, because I think if we look at the Dogen test, which I think, Dogen org product test, I think this is the only one that's updated with the latest. You can see here that we have a builder, and the builder creates a configuration, and then we just pass the configuration to this guy. So I suspect we might be able to get away with just using that approach on the production tests. And that might be all the cases where we use the factory. Of course, we could very easily ask for references and we should see well, it's used on conversion as well, and in the byproduct test. So I don't think it's too bad, really. So I think we could probably, well, let's start by getting rid of the model production, because I think, as you can see, these uses here are external to the model producer. So the first objective here will be to tidy up the model producer API and just have one single way of calling it that doesn't rely on the factory. Then we will worry about the rest. So that being said, I think this is going to be just a copy and paste exercise, so it might be a bit boring, but we just need the builder here, and that will be anywhere around here somewhere. So I think we just need the builder, and then we just need to, right, so I see we're setting up the builder here with the read environment. I think we need something similar. We don't really care about the fixed activity timestamp. So interestingly enough, it doesn't really look like we're going to really need a method to set up the builder. We'll probably just create the builder in each of these methods, and we can call it B. And of course, you're going to need to use somewhere around there. This makes me wonder, actually, if we can't support another method that just creates the configuration internally. So perhaps we're being a bit too hasty here. Let's say that we could keep the factory, well, the generator, with more than one call. Well, actually, we could now call it a producer. So let's say that we do need a producer with more than one call, but instead of supplying the configuration, okay, so how exactly did this work? Because in the past, yeah, so perhaps we, in fact, so what we really want is, so the logic here is that we would like to set up the builder in one of two ways. In fact, I'm beginning to think we kind of made a mistake on this approach, really. Really, what we should have done is we should have created a variable at the top level. So we have two use cases, really, if you think about it. We have the use case where we want to read the environment, and that requires us using the fixed activity timestamp. And we have the use case for everything else. And when we call this method here, we still would like to have the flexibility of supplying these flags, because the good thing about these flags is that they enable us to, with just one change here in the test, they enable us to obtain more information without having to modify anything. So I don't really want every single test to have to set up a builder, set up these flags, and then call this method, because that means that I'm going to have to duplicate lots and lots of lines. So I think this API is actually the right API, believe it or not. What we really need is a bit of state, perhaps, inside of the producer to say whether we're going for this use case or the other. And that would then determine how the builder is set up. That being the case, we could just have a so instead of having lots of statics as we've done here, we could actually have well, these could remain a static, it doesn't really matter, but these guys here could now have state, and there could be a flag for the producer that determines whether to read the environment or not. And actually, I probably will call that enable full generation for that flag. That will then trigger the builder to work slightly differently. we still need these guys here, which now makes me think that perhaps the whole story about the builder was not actually brilliant if you think about it. So this is exactly what happens sometimes. You come up with an approach, you think it's a great approach when you have 5 minutes to think about it, and then when you have a bit more time, you reflect on, especially after you've implemented it, you reflect a bit more on what's the right way of doing things. The truth is, we only have one place where we are required to read from the environment, and that's the model generator. No one else is using this functionality. So, and that then reflects on how we set up the configuration. So one begins to think whether it would not be more sensible to just have some state in the builder, no, sorry, not in the builder, but in the producer, that then determines whether or not to do these steps here. And now the builder makes a bit less sense because, as you can see here, the real use case for this API is to supply these flags. That's what we really need, because we want to be able to say, oh, for this particular test, just I would like that to be true or false. And at present, I need a whole builder to do that. I need to do it here locally. And now I've duplicated all these lines with the builder and so on. So that's not very nice. So I propose instead that what we do is we get rid of the builder, which is a bit disappointing since we created the builder specifically for this. Instead, we make this chap an actual object with state, supply it a flag, check the flag before generating the configuration, and then if the flag is true, then do these 2 steps. If the flag is false, then don't do those 2 steps. And that enables us to keep the API as is. We do have to have one additional line, which is we need to create a model generator locally with a flag. But still less than 2 lines for this particular case, plus the increase of the API there. So that seems to make sense to me. So let's think about this then. So if I just, let's just start by putting some state here then. I'm not sure why that happened, but bool. In fact, I'm going to go for const bool use. Max, slowing down a bit. We still have this annoying error. We need to restart the max. Full generation. Now, of course, it's annoying to have to go backwards and forwards in these sort of approaches. I would rather do it once and do it right, but this is the story of programming, really. So if I just say that there is a constructor which takes this guy as an argument, excuse me, this cough is still ongoing. So then, let's just say that our constructor takes these guys as an argument, and in that particular case, we do that. But if we don't bother, in fact, we might want to, well, because this is const, I think we have no option but to have 2 constructors, and in the case of defaults, we want to set that to false. Now, what this enables us to do now is to determine how these methods are going to kick in. And then what we can do in this particular case is we can say, well, I no longer want a config to be supplied as a parameter. I would like that to go away. Interesting. So this is where these code actions are quite useful. So I assumed that in the new world of initializers, this use case would still require one to want to create a default constructor, but according to this, you don't. So that's very clever. So now then, now that we've done that, what we need to do now is to say, instead of a builder, I don't know why Max is actually stalling so much. It's definitely something to do with that 3max error. So in this particular case, what we want to do, actually, of course, we forgot one very important thing, which is none of these methods can remain static because we now need state. And then in this particular case, so we will not worry too much about this guy here because this guy is a subset of the rest. We will worry about these other guys. What we want to know is, we already had some kind of basic support for reading. Yes, here we are. So, right, so what we were doing before is we were determining whether to read the environment or not. So now we just have to diff the factory with the builder, I think, because there was a bug in the factory. Right, as you can see here, this is a much nicer way of doing this. So this guy goes and reads the variability override. And so we want something like this. So let's just add that to the generator, producer, sorry. Perhaps we could add it here. Out of curiosity, did we already? No comments, so let's just add some comments here. So reads. So I think we could just get rid of the statics, since everything is static in this class, I think. And so reads the variability overrides from the environment. Now, as you can see, the naming is very, very all over the place at present. So we are not quite sure exactly how this is going to work. So this guy reads variability overrides. This guy makes the config. I think I'm going to put this guy next to that guy because I think it makes more sense. And where we are making the config, we need read variability override. And then we just need to see, so it just needs to be a model producer. We just need to see how this is being used. Yeah, so as you can see here, we have two variables that are controlling this. Right, so read environment is this guy here. And I don't think it makes a lot of sense to have a read environment globally because we never really need that. So we'll just stick to read environment. And then when we do read environment, we then do what needs to be doing. Done. And we also have the use fixed activity timestamp, but we do know that we always use fixed activity timestamp when we read environment. So I think we just need to really fix the naming here because these names are all very, very confusing. So this reads variability override. So read environment doesn't seem very meaningful, really. What do we mean by read environment? Read from the environment? Read environment variables. I mean, that could be any environment variable, really. So how do we... So this is now populating the config. So maybe it makes more sense to just call all of these with full, but then of course we don't read. Okay, so the good thing about read environment is that we don't know whether full generation is enabled or not. So what we really want to say is if full generation is enabled, then we must use fixed activity timestamp because they're dependent on each other. So really, read environment is not a bad thing. So we'll stick to read environments. We don't have a need for locally and remote. So we'll just say that there's just a read environment. And then instead of all this logic of full generation, you're going to say, where do we put this? Right, so this is using the factory now. So I think we just have to get rid of all of this. Then we go to the factory, we create a config, and then off that config, then what we do is we say, actually not all of this, but instead something more like this. So this is a bit confusing, but I think it will make sense in the end. So what we do here is we say, well, if the user requested full generation, actually we don't really want to call that full generation. So if the user requested read environment, variables even, okay, if the user requests us to read the environment variables, then we basically read the environment variables. Now we must make sure the make configuration is no longer, so this is obviously going to now start pulling in all of our statics, which is fine. That's not a problem. So we'll say you're no longer static. So if somebody requests this, so I probably I prefer actually the positive rather than the negative. So let's just say that the else is this guy here. So if you've decided that you need to read from the environment variables, then read variable overrides, create it, and the return now contains the overrides, or if there are no overrides, else we want that. And the case of this guy, we will say, well, actually, he didn't even ask me to read from the environment, so don't bother with that. And then, apologies for that. And then what we also need is the activity business, which you can also get from our builder. And the builder will say something like, if activity, use for activity timestamp. So now we know for sure we need the activity timestamp because there are some overrides. We can say something like full generation requires us to fix the activity timestamp to a well-known date. Time point. This is because we need the tests to match the code that was originally generated by the build. Okay, so this will allow us to remember what it is that we're talking about by the time we get back here in a few months' time. Okay, we seem to have a problem with reading variability overrides. Well, I think the biggest problem is that this is not static. Right, so that's not a problem. No. Okay, so let's just think about this for a second then. What is it we're trying to do? So we now have state. We removed the builder, hopefully, and we will read the environment variables and do the right things in this scenario. Let's just make sure that this is okay. Yeah, that looks fine. Okay, so now then, of course, this breaks everything now. So we need to now go to the tests. Let's start with the Dogen tests. And we need to say that actually we want a model generator. So this is actually called a model producer. So if I just say we are using this chap, and if I just say that instead of a builder, which is about to be deleted in a second, so instead of a builder, we want to just generate the producer, which in this particular case, model producer will have true, and that is the variable that we just created. So now we have a model producer here, and we could just say something like model producer.apply, and that check there. And check for differences now becomes model producer.check for differences. We don't need to build, and we probably could move the model producer to here. Okay, so as you can see, this is slightly more concise. It solves the problem that we had before. I think what we need to do now is just go around. I think, because we've been very careful to make this code very similar, we should be able to literally just go around copying and pasting, I think. Hopefully. It's paying off the similarities in code in the tests. I do like my tests to be very simple, and sometimes they're a bit repetitive, and it does look like a copy and paste job, but it pays off because when you are trying to understand what broke, it's actually quite easy. So for instance, in fact, to be honest, the only thing this test has that annoys me is the little bit of duplication and things like check for differences, which should be part of this method. But that's really to do with the way Boost's test works. We probably need to figure out another way reporting the error where it happens, but for now, it's easy enough. So hopefully this will solve our problem. This also illustrates the problem that we have when we have limited amount of time to think about something. Sometimes we come up with a solution and then 5 seconds later we decide it's actually, or a few days later, not the best. That's a disadvantage of working with short time scales. Right, now then, hopefully, I was expecting these guys to error actually. Right, okay, that's better. So, can we copy and paste here? Sadly, no. So we need LD, comma M. No, T, comma OD, sorry. Okay, so we just get rid of this guy for a second. This now becomes the truth, and hopefully we can just do this. Oh, actually, of course, we're going to have to be like that. So again, because our test should be very regular, it should just be a case of going around replacing these two lines. With 3, so it's growing, sadly. But such is life. But again, as you can see here, everything is very regular. It doesn't require a lot of creativity. And of course, you can imagine in the future, once we figure out what this pattern is, we can just create a simple code generator for this, such that we just need to change the template. That will be the ideal scenario. One single change, regenerates, and all of this will be done for us. That's kind of what Dogen is here for. This is another reason why you see my code. It looks a bit strange, I guess. We have a lot of okay. We have to slow down slightly. What is happening here? There's a few tests where we are enabling reporting locally. Now, I'm not sure why we did that. I suspect this is an old thing. So let's just go back to our model producer. I think reporting is already enabled globally, so there's no need to enable reporting locally. So I think, again, this is something that also happens. We probably were investigating some issue. We forgot to disable it, and now the pattern stayed there. I don't think we need that anymore. Well, in fact, I'm sure we don't need that anymore because we are enabling reporting globally, which probably makes sense really because it's not that time consuming. So that should help. Okay, so that's the tidy up for the ref impl. I suspect very much the same will be needed for all of these guys. So start off with the top. That seems to be the one we just did. And as you can see here, we're going to have loads of these. So as you can see, this is definitely the sort of thing we should be code generating, but we're not. So let's just double check this will make sense. Yep, it does. So usual changes. Now this is going to be a bit boring, but has to be done. Also illustrates a bit what the real activity of a programmer is sometimes. Not particularly glamorous. Also explains why it is that I believe so much in code generation, because I would want the code. So there are two ways of solving this kind of problems. You could, which is what we do in production, we could create lots of methods with lots and lots of parameters that enable you to cater for all these different use cases in the testing setup. And this is what we do in real code. We wouldn't really be copying and pasting like I am doing here. But then the problem with that approach, and this is, for example, what happens in industrial code. So if I was doing this at work, I would not be copying and pasting. I would have created a method that abstracts a lot of this logic here, and that method would be very terse and would do lots and lots of different things. And everyone in my team would be happy that I've done that because no one wants to be copying and pasting like I'm doing right now. So that's how the things work in the real world. But then the downside of that, especially somebody who's been doing this for many, many years, is that you end up with test code that's actually almost as complicated as production code. Because if you think about it, there's so many permutations that happen in test code. And these permutations are not trivial, really. If you take into account all of the variations we got here, we would be creating tests that have to have a lot of ifs and buts. And what tends to happen then is that when something changes in a test, and you have to go back and change these tests, then it takes you forever to understand how the tests hang together. Well, it's just as it would if you were trying to change real production code. But the difference between real production code and test code is that test code is created only for the purposes of testing something. And if test code is really complicated, then you don't really have a lot of confidence that you're testing things properly. So you don't really want test code to become as complicated as production code, because there are no tests for tests. That's an important factor to take into account. Your tests have to be so basic and so simple that you can almost axiomatically determine whether the test is correct or not. It's no good if your test is so complicated that it takes you a while debugging and so on to just understand whether the test is right or wrong, because it defeats the purpose of the test. But in reality, once you start doing what I just suggested, which is to factor out all this common code into some base class, either by using normal functions and methods and so on, or if you have a more modern language by reflection and so on, the code will no longer be trivial. And at that point, you've now created another problem. So as JWZ would say, you had one problem, now you applied complexity, now you've got two problems. So that's not ideal. So all of this to say, interesting, yeah, we got. So all this to say that the reason why we're experimenting with lots of copying and pasting in Dogen is to see whether the trade-offs that we normally make may not necessarily be guided by the right option, the right choices. We are guided by the fact that we have limited time and we don't really like copying and pasting. And remember, there's lots of problems with copying and pasting, right? Copying and pasting still means, like what happens now, I made a mistake, I want to change something, I need to change that in loads of places. I mean, of course, you know, I don't need to do this. I could easily create a macro in Emacs, and Emacs will do this for me. But as it turns out, it's easier to do copy and pasting while you're writing a video than it is to try to create a macro that requires thinking. Copy and pasting is actually quite suitable for recording. But nonetheless, that's not what we want to be doing, really. We don't want to be doing code like this. But why do we do it in Dogen? So the first point is that Dogen is trying to look for regularities in code. And one way to express regularities is by saying, write something the simplest possible way. And even if you have to double check that this is actually working. I think we did something wrong somewhere. And even if it means lots of copying and pasting, it doesn't matter. Just do copying and pasting, but just keep it really simple. And then eventually observe a pattern on all the code that you copy and pasted, and then reduce that pattern to a template. In other words, co-generate, not quite sure what's going on anymore, co-generate the pattern. And so what really should have happened is, if Dogen was ready, is we should have observed this pattern by now, and we should have created a template that generates these tests. And this template would probably be only applicable to Dogen itself because it's so specific. And then now, at this point in time, we'll be applying a change to the template, and then we'll be regenerating the tests. And so there'll be a single change in one place, and also will mean that we don't lose the ability to see very, very simple code from the perspective of debugging, because the generated code will be very, very simple. But we'd have the best of both worlds because we also have a single place to maintain rather than what I'm doing right now, which is hundreds of places. Of course, when you're generating the code generator, there's this in-between states where the code generator is not ready. So you must continue to do things the hard way, which is by hand, which is what we just did here. It's not nice, but sadly, I don't think there's an alternative to it, because until we finish the code generator, well, there's not much you can do, really. But there we are. We finished our changes. Now, we won't actually know whether this has worked or not until the nightly. I mean, I've been a bit lazy and I didn't put a test for full generation in the tests. But it's fine. Like I say, we can't test everything, so we just have to continue as you are. We have code generation differences, interestingly enough. Slightly unexpected. Okay. Okay. So I think all that's happened here is that we've gone a little bit too far in the copying and pasting, and then some tests were slightly different. So I think we just need to figure out what tests these are. not failing everywhere. How many tests do we have? Failures, 6 failures. Okay, let's just have a quick look at the first one. So the rough input diet tests, and the test is forced right. Okay, this seems like something we would require some additional setup, but that's fine. This is expected. So C++ rough input diet test. Let's just have a quick look at this diff. Unfortunately, Emacs likes to put diffs somewhere miles away. If we look at the test, for some reason we're in C#, not C++. Okay, that's better. Right, so there's the test. Now, very carefully, let's look at the options. So, tracing and reporting, we don't care about that. Check for force right. So as you can see here, we slightly have a different check for this guy. So all we need to do is to go for here and replace this with that. And I believe that will solve that problem. Now, this won't be the only place. So I just do a search for force right. Right, so that's the only place in this test. I suspect it will be the only place where we have the force right. So let's go back to tests. And the next one is this guy. Out of sync. So same thing. Let's just have a quick look. Check. We have an out of sync. And I bet you the check will be slightly different. So we replace the check. And presumably the next guy would also be out of sync. That is the JSON version. So I'm actually just gonna use my knowledge of the code base to just jump over to the JSON and replace this, and presumably that'll be an equivalent org, which will also be out of sync. And now I would also assume C# would have, it does not, well actually just run the test again. Hopefully this will reduce the number of failures. Still have 3 more I suspect, but at least not 6. So what are we doing for time? 48, so I think that's all we're going to do for this video. Here we are, 2 more failures, and if we just have a quick look at the name of the test, force right. So C++ ref input is a force right in JSON and in org mode. So force right, and all we need to do is the exact same thing. Look for force right, replace our check, and similarly replace our check. So the copy and paste, again, you can probably see here why people hate for copy and paste. The code looked rather similar, but it was not identical. Tiny, tiny differences. You get into the copy and paste mode, and then you will break things. So of course, in the real world, copy and pasting is very, very bad idea outside of model-driven engineering. Here we are, so everything's green. We go up to this guy here, and I'm not going to bother clocking just yet. We will say perhaps something like what should we say? Something along the lines of, we don't need the diff orchestration. add state to model producer. Remove uses of builder, rely on state instead. Okay, so if we did our job correctly, if we just go over to modeling and we look for model, if you're in the right model, of course, orchestration. And if we just look for model builder, maybe mock. Actually, no, sorry, we were in the wrong place all along. So dogen.org, mock configuration factory. So mock model builder. I think I like that commentary, so I'll leave it there. But I will get rid of model builder. So let's just build the latest code generator, and then let's generate everything. And then hopefully in the diffs, we'll see the builder got removed. And now let's run our tests. And we can't just do that because, of course, this is CMake, and it doesn't always detect changes to files. So here we are. Okay, we need to generate Plantium now, sorry. Right, so at this point in time, hopefully the uses of the builder have been removed, and removed the code to where it should have been in the first place. This also means we have to worry less about the flags, I think, because suspect the flags we used. While we do that, let's have a quick look at where we're using the flags. I think it's only using the model producer. You can see here we have the global flags here. Don't think when we said there are flags everywhere, I think what we really meant was these flags here, plus the flags in the builder, and I don't think the factory contains any. As you can see, it does not. So I think that's all right. So that's everything is green here. So I think we can clock this story to be over because we removed the mock configuration factory. It took us an hour, but we did it. And we don't have to worry about the flags. In fact, we did do some work on the flags because if you remember, the tests did have a few random flags somewhere. So let's just basically say Dogen remove mock configuration builder. Right, so it was a bit of backwards and forwards here with this configuration builder, but I think we were all the better for it. So for our next bit of work, not sure if I'm going to record a video for this, but as far as you're concerned, I think the Dogen product is now finished. We resolved all the problems here. We did a bit of a tidy up as well. We hopefully resolved the Valgrind problems. So next is our friend, the C++ reference implementation. We still have these failures here. We don't really touch this in a while. Perhaps something to look at. And we don't even have nightlies and so on. I don't think I'm going to bother creating a video for this because I'm hoping. If I go up to docs, oh, there is no docs. GitHub, perhaps. CMake. So if I go up to CMake, I think we can probably get away with very much just copying and pasting these, because I don't think there's anything specific here to Dogen. And in fact, if we were to generalize this Dogen build provider, well, actually probably can't because there's some reliance in this somewhere else. Probably in the ctest script, but I don't think maybe we're being naive here, but I don't actually think this guy's going to have huge amounts of dependencies on Dogen. Yeah, I actually think these files are now very much a template. Ah, okay, slight change. We don't really need this guy here. But I don't think I think it's going to be almost a copy and paste, really. Again, as you can see here, this is why we want templates. So I don't think I'm going to bother doing that because I think it's going to be very quick. With this, I think we call it a day. We pretty much have done all of the work required to remove all of the stuff that was not necessary. And we will continue hacking around in the next video. Thanks for watching.